Hello everyone and welcome back. My name is Mr. Cobalt and in this video I'm going to go over how to write equilibrium constant expressions for heterogeneous equilibria. So let's get into this. So what do we mean by heterogeneous equilibria? What we mean is that you have a different states of matter for the different substances in your equation. So that means basically that you're going to have things other than gas and aqueous. So if you remember from a previous video, so when you're writing your K expressions, whether it be Kc or Kp, we only include things that change in concentration over time. So that would include gases as well as aqueous solutions. Solids and liquids do not really change their concentration over time. So we don't include those. So that's why we call it a heterogeneous equilibria, where you have an equilibrium reaction where you have gases maybe mixed in with solids and liquids or aqueous, right? So when you have solids or liquids as part of your equilibrium reaction, then that is considered a heterogeneous equilibria. And so when we write the equilibrium expression for the constant, the equilibrium constant, we leave out anything that is solid or liquid and just include gases and aqueous. So let's go ahead and do these two example problems. So for A, we're given the reaction at equilibrium of SO2 gas plus 2H2S gas. And that's in equilibrium with 3S solid and H2O gas. So in this case, again, the expression of your K equilibrium constant is going to be the product of the multiplication of the products over the reactants raised to their powers of their coefficients. So we're going to start with K, right? So K is equal to, it's going to be products over reactants. So here we want to write the Kp and the Kc. So we're going to do Kc first. So Kc is equal to the concentration of products. So we're going to have the concentration of water. We're going to ignore the solids. So this here, we're not going to put into our expression. That does not go into the expression because it's a solid. It does not change its concentration over time. And so here we're just going to use the gas. So we have water, gas. This is going to be the concentration of H2O. And its coefficient is 1, so it's raised to the power of 1. We don't write the ones. And then we've got these two gases as our reactants. So we're going to have the concentration of SO2 on the bottom, and that's going to be multiplied by the concentration of H2S also on the bottom. And since we have a 2 here, that's going to be raised to the power of 2, and we're going to write 2 powered. This is to the the coefficient of 1, so that's going to be raised to the power of 1, so we don't write the 1. But it's understood to be there. So here we have the Kc expression. And then the Kp expression is exactly the same, except it's in terms of pressure. So Kp is going to be equal to the partial pressure of H2O gas over the partial pressure of SO2 gas. So partial pressure of SO2 gas multiplied by the partial pressure of H2S gas. Forgot the pressure. So it's going to be the partial pressure of H2S, and that's raised to the power of 2. And so that, ladies and gentlemen, is the Kc and Kp of this heterogeneous equilibria equation. So let's go to the next one. Here we have TiCl4 liquid plus oxygen gas, O2 gas, in equilibrium with SiO2 solid plus 2Cl gas, Cl2 gas. Once again, if you have solids or liquids in your equation, you're going to ignore those when we write our Kc and Kp. And we're only going to include aqueous and gases. We don't have any aqueous, but we got gases here. So for Kc in this case is going to be equal to the concentration of Cl2 raised to the power of 2 because it has a 2 coefficient. And since this is liquid, we're going to ignore this. So it's only oxygen is left. So we're going to have the concentration of O2 on the bottom raised to the 1 power because it has a 1 coefficient. And so this, ladies and gentlemen, is the Kc expression. And the Kp expression is exactly the same, except now we're dealing with partial pressures. So Kp is going to be equal to the partial pressure of Cl2 raised to the power of 2 over the concentration or the partial pressure of oxygen, so PO2. And so these are the expressions for Kc and Kp for these reactions. Again, if you have a heterogeneous equilibria, that means you're going to have solids and liquids also mixed in with gases and aqueous. And when you write your K expression for your given equation, you're going to include everything except for solids and liquids, because solids and liquids are not going to change concentrations, and we are not going to put that, therefore we're not going to put that into our equilibrium expression. So that's it for the video. I hope this was helpful in any way possible. I hope you enjoyed the video. If you did, then please like the video, share the video with your friends, hit the like button somewhere over there. Also, make sure you subscribe to my channel, hit that notification bell. When you do, make sure you click all, and put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a question or a problem you want me to help you with, put it down below. If you have a topic you want me to cover, write that down below, and I would love to do that for you. Thanks for joining me, and have a great day.